So cool. Welcome everybody. We are recording now. And yeah, let's get this party started here with our agenda. But first, this is our second virtual Spirit Week. So Spirit Week number 2. Thank you ASB for putting this out. Yesterday was Mellow Monday. I forgot to post a pic of myself in my favorite PJs. Man, oh well, I guess I'll get by without that. But yeah, today is TikTok Tuesday. I don't have a TikTok, so I can't post myself making one, but y'all can if you want to share it out on the classrooms, as long as it's appropriate. I'm always cool with y'all sharing some individualized stuff. So if you're making a TikTok or if you just have a favorite TikTok that is appropriate, feel free to share it. Wilderness Wednesday is tomorrow. So tomorrow, if you can get outdoors responsibly, away from people and socially distant, take it at a time and do so. I'm always a big fan of getting outdoors anyways. I think it's good for your mental health to get outside and see the sun. But specifically, since tomorrow is Wilderness Wednesday, make sure you post a picture of yourself outdoors in a responsible manner. Thursday, the next class that we have is Throwback Thursday. Post your favorite throwback school pic. So some of y'all, maybe in your elementary or junior high days, I'll try to find some pictures of me from my high school days or whatnot, and I'll post those up. And yeah, Friday is Feel Good Friday. Compliment someone to make their day. Always do that. So let's start off with, I'll actually jump a little Feel Good Friday today on Tuesday with our announcements. So one, and the most important thing, is keep up the good work, okay? I sent out the progress report grades yesterday, fourth quarter progress report, and they look solid. A lot of y'all doing really good. A lot of you that are in here right now have been really up to date on your homework and your Edpuzzle completion, and that's showing in not only your retention of the material, your understanding of it, but also your grades as well. Scores are looking solid, but I want to continue to encourage us to keep up the good work. We have 5 weeks left until summer. We're on that home stretch of a really crazy school year. So for all of you who were either new to Valencia in one capacity or other, or just second or third year of Valencia, it's been a crazy year and it's been tough for all of us. I know probably you more than some others, but I really appreciate how hard you're working. Okay, I can't stress that enough. Learning math online is very difficult, and I'm really truly appreciative of the work that you've been putting in towards that. It makes me smile literally every day, even when I'm grading work. So solid work, keep it up. We're almost there. Number 2, Edpuzzles. Keep on keeping on with those Edpuzzles. They keep coming in like a tide on the ocean, but they're there for our help with the material. The new Edpuzzle is posted this week. It's on factoring because that's what we're doing. All the old puzzles are still to be available to be completed, which means even if you missed the stuff from the last module, our parent functions, 6 basic parent functions, there were 2 of them. Go back and get those done. If you get both done, you get full credit on those scores in your gradebook, regardless of what you actually got. Okay, sweet. Remote learning agenda and RLQs, I want to really stress to use them. I mention it every week, but I'm going to actually dive a little bit deeper into them today, give a little bit more insight, so that way we're understanding what I'm talking about when I say remote learning agenda and RLQs. Remote learning agenda is this thing right here, this Google Sheets. Notice, there you go, we actually did that last week. We are on 428 right now. So we're continuing our journey through lesson 14, factoring. And then on Thursday, which will be the last day in April, 4:30, we will move into lesson 15 where we'll continue working on factoring. But the main thing I'm bringing our attention to this is that this sheet right here, this agenda, is posted on basically all major classroom posts. The stuff that I do on Monday when I send out that welcome video, look forward to seeing you today. Every single Zoom session, I throw this on there, and on the kind of week recaps videos that I post on Friday now. I try to put this up there as well so y'all can see and have access to this agenda so you know not only what we're doing each day, but also when things are due. This column over here, all the stuff with like 5/5, 5/15, those are due dates, and the assignments as well. The purple column is the extra assignments, those Edpuzzles, and all that good stuff. Last but not least, I really want to talk about, and we'll go in more in depth in this a little bit later on, but the final for this class is going to be something that I call portfolio project, and it's called the portfolio project because basically you're going to have an option of showing me that you know the material in a variety of means, meaning you want to write a short little paragraph, you want to do a slideshow, you want to make a Kahoot, you want to do a recording of you doing a problem, or so on and so forth. I will give you guidelines as we near that, but the final in this class, just so you have a little information as we continue to move towards these last 5 weeks, or through these last 5 weeks, is going to be kind of a, you pick your process and you show me you know what you're doing in terms of quadratics and other equation solving. Okay, so that's kind of where we're headed. More to come on that in the near future. Sweet, remote learning agenda, check. RLQs. RLQ stands for Remote Learning Questionnaire. And RLQs are those Google Forms that I put up also continuously. Try to get your questions. They look a little something like such. Okay. This is the one for this week, also posted in today's announcement or today's Zoom session announcement. But I've made a subtle change to it. Instead of just asking what you need help on, I've also thrown a couple of other questions in there, specifically, how are you feeling? And how is this learning process going? Do you have any recommendations? So you could interpret that first question, how are you feeling, in a variety of ways. How are you feeling just on a personal individual level? Or how are you feeling with the material? Or how are you feeling with school or life? And everything is all open and fair. Also, how is this learning process going? I mentioned I know that math is super hard to learn online, especially in this form. So I know it's not perfect, but I'm just kind of trying to gauge how you're feeling about this learning process. And if you have any recommendations to changes that can be made, I'll try to take those into consideration as we progress through the last 5 weeks. So feel free to fill this out in your own time if you would like to. Again, not mandatory. Just feel free to do so on top of any and all homework questions that you ever have. I'd be happy to answer those as well. Sweet. So those are our learning agenda and learning questionnaire. That is done. PowerPoint notes posted. We used them last Thursday. We're going to use them a little bit again today. And I want to mention where we could find those PowerPoints posted. None other than our Google Classroom. So whether you're in period 5, 4, 5, or 6, I'm just going to look at period 4s because it's basically all the same thing. So where we could find the notes is we could always go to this classwork section, which is where y'all have been uploading all of your work. Again, very good job on that. We're now in module 4. So when you go down to module 4, there's something that's called the quadratics bundle. It actually has more than 6 attachments now because I posted these notes. But down here on those Google Slides, the little yellow chapter 8, chapter 9 stuff, that's where you can find any and all of these notes that we're soon going to use to continue our conversation on factoring. Please use these. They were created for previous classes of mine, but they really work well for the material that we're on now as well. They give a lot of information that I can't spend or don't have enough time to really give you an in-depth information about during these Zoom sessions. So use those as a reference or as a tool, however you see fit. All right, last but not least, Zoom sessions, office hours, Friday at 10 a.m. Hope to see y'all there. Some of you have been doing a really good job coming to those. Again, I'd love to see you there. If you have a homework question, have any questions, I'd be happy to answer them then or via email, and also just see your faces and say what's up. So without any further ado, do we have any specific class questions before I move back into lesson 14, our material for today? If you do, either unmute yourself and let me know or type it in the chat box and I'll be happy to answer them. If you don't have any right now and something pops into your head in the near future during the session, never hesitate to ask. I'd be happy to answer as well, okay? All right. Cool. So then on that note, let's get this party started here in lesson 14. And back last Thursday, when we first introduced this idea of factoring polynomials, we introduced the tactic of the X method. So this is on page 502 in our vocab. I'm just revisiting this just to kind of flash back to where we were 5 days ago, since it's been a while. The X method is what we're going to be using today, and the whole point of X method is to factor by grouping when we have uneven terms or more than 2 terms. And the factoring by grouping is just the opposite of the distribution process. So we're really focusing on undistributing when we factor by grouping. Those are the 2 main phrases in terms of today's material. Let's take a look at it. So, nope, not there. Okay, so those notes that I alluded to, the PowerPoint notes, which let me actually just show you what they straight up look like, that you can find on that quadratic bundle look a little something like this. We started working last week on seeing some of these slides for the process that we did last Thursday. We got all the way about to right about here last Thursday. Now, what I really want us to focus on today is factoring trinomials like such. And we did this on Thursday as well. We just didn't see these slides. So ax squared plus bx plus c, that's that quadratic standard form where they're just the numbers in front, can be done by factoring or the opposite of distributing. So the main thing that we're going to take today, and keep in mind that this screen that you see here basically gives you a step-by-step process of what it means to factor. I'm going to switch to another page in just 1 second, so you'll see this screenshot pop up over and over again. But I will also upload the notes that we do over the next few minutes to the Google Classroom as well today, okay? But effectively, what we learned on Thursday is the following. And here's, again, that screenshot. That if we were wanted to factor a trinomial, like x squared plus 6x minus 16, we try to look for a common factor first, and then we realized that we didn't have any, nothing that we could take out of all three terms. Yeah, the first two have x's, but the third one doesn't. So x isn't a GCF because it's not common amongst all three. Yeah, these two have a common factor of 2, but the first one does not because, again, that 2 is an exponent, not a number, not a coefficient. So when we're trying to factor a trinomial, and trinomial meaning 3 terms, 1, 2, 3, we try to factor by grouping. So the way that we do this is through that X tactic, and the X tactic isn't called the X tactic because of the variable. It's called the X tactic because we use this little X chart over here, independent of the actual problem itself. Excuse me. So again, these are actually not in your text, so if you want to take notes on this on a separate sheet of paper, please feel free to do so. But I will also be uploading these to the Google Classroom as well, and y'all know that you can always find this recording on the YouTube channel. So very first thing I want to do is multiply the leading coefficient, which is a fancy way of saying the number in front. Multiply the leading coefficient by the constant, which is the last number. So that means I'm going to take the number in front, which in this case is invisible, but we know if it's not visibly seen, it's got to be a what? A 1. I'm going to take the number in front, 1, and multiply it by the last number. First times last is the way I always kind of refer to it. First number, 1, times last number, negative 16. And then we drop that number back to the X chart, boom, right up here, the top of my X. What's 1 times negative 16? Well, none other than negative 16. Boom, step 1, done. Step number 2, we want to find the factors from step 1 that add up to that middle term. So what we did on Thursday is we said, all right, we populate the top of our X, where the marker is right now, where the laser pointer is, by doing the first number times the last number, in quadratic speak, A times C, and then we take the B value, which is 6, the number in front of X, and drop it right on down here. Now step number 2 is basically saying the following. We want to find the factors from step 1, factors of negative 16 that add up to 6. So what factors of negative 16, what numbers would add up to positive 6? And for those of you that were here on Thursday, maybe you could try giving this one a go. We're trying to find the factors of negative 16, 2 numbers that multiply to negative 16 that if you added them together would be positive 6. What do y'all think? Move this down here real quick. Expand it a wee bit. Anyone think they know what factors of negative 16, excuse me, might add up to positive 6? 100% correct, Skylar, that 3 plus 3 definitely does add up to 6. But my question, I guess I would build off of that is, does 3 times 3 equal negative 16? Because we're trying to find the factors of this number here, negative 16. The factors of the top that add up to the bottom. So 3 times 3, or 3 plus 3 does equal 6, but 3 times 3 does not equal negative 16. So great call. Anyone else have a guess? If we don't get one in about 10, 15 seconds, I'll definitely jump into and give you the numbers. This one's kind of tricky. Remember, the only way to get a negative product is to multiply one positive times one negative. So I'll give you a hint. One of these numbers has to be a negative number, and a positive number. All right, I got you. Here you go. Ready? The factors of negative 16 that add up to 6 would be negative 2 and positive 8. Because after all, negative 2 times 8, negative 2 times 8 does give you negative 16. And negative 2 plus 8 does give you positive 6. So step 1, take the first number times the last number, boom. And then we want to find the factors of that add up to our middle number, 6. And those factors in this case were negative 2 and positive 8. Last but not least, step 4 and step 5, we're going to replace the middle term with 2 factors. So now I'm just going to cruise on down here. I have a little bit more of a clean slate here. Remember, this problem was originally x squared plus 6x minus 16. We said that our x chart, let me just copy and paste it. This x chart right here came from the following. The green up top, negative 16, was a product of the first and the last. The orange, 6, came from that middle. And then y'all just, as a class, we just came up with the fact that, oh yeah, these two can replace that middle. So step number 4 is basically saying the following. Take the problem x squared plus 6x minus 16 and rewrite it as follows. Instead of that 6x, we replace it with negative 2x and positive 8x. So if you were here on Thursday, what we now have done is we have expanded that middle term. We took something that had only 1, 2, 3 numbers, 3 terms, x squared 1, 6x 2, negative 16, 3, and we made it into 4 terms, 1, 2, 3, 4. So now we could, last but not least, factor by grouping. And here's how we factor by grouping. Well, we use grouping symbols. Group number 1, group number 2, money. And now we try to take out GCFs, meaning looking at my individual groups, what can I take out of both of these terms? Does anyone have an idea? What can I take out of both x squared and negative 2x? No doubt, Francis, great call. They both have an x in it, and they're both just regular x's here, like x's without an exponent in a sense. So x can be taken out of x squared, and here's how, ready? X squared, just I'll erase this in 1 second, but x squared is the same thing as x times x. So if you take one x out, all you're left with is one more x. So removing an x from an x squared, you get an x. What happens when you take negative 2x and then you take the x out? You just have a negative 2 or a minus 2. Cool. So that right there is just what happened when Francis factored out the GCF of x. That is just the first one. What is the GCF of my next 2 terms? What can I take out of both an 8x and a negative 16? 8, good call, Andrew. So we could take an 8 out, and I'm going to remind myself that it's a positive 8 with a little plus sign. Oh, a positive 8, cool. And what happens when you take the 8 out of 8x? Again, one more time, notice right up here, literally 8x. What happens when I take the 8 out of it? Boom, it's just an x. And what happens when you take negative 16 and divide it by 8? You get what? Negative 16 divided by, taken out an 8, gives you a negative 2. Cool. The final kind of magic trick, the aha moment that we saw last Thursday was the following. Do y'all notice anything about these parentheses? And that's the end game. That's always the goal. When we get to the point of factor by grouping, our goal is to get these parentheses to be the same, and boom, we did. Our parentheses are the same. So here's what we could do. We can combine the GCFs. X and positive 8, and by the way, that's why I put a plus sign to remind me it's positive 8, x and positive 8 times x minus 2. And there is our undistribution. We basically just did the reverse of the distributive property to factor that problem. Sweet. And that again was a reiteration, a repetition of what we did on Thursday. The material that we're learning now to factor polynomials is, in my opinion, the hardest part of algebra 2. Algebra 1, and sometimes the hardest part of algebra 2 as well, because we actually do stem back into this in algebra 2 as well. So there we go. Let's try to repeat this process with a little bit more difficulty, okay? Because all of the examples that we've done thus far have always had, in every single one, have always had a leading coefficient, an a value that was 1. But not all trinomials, not all quadratics or equations that have a power of 2 have a 1 in front. So we're going to cruise on down here and try a little bit more difficult one, okay? So again, to factor a trinomial, first thing we always look for, no matter what we're working with, is always trying to factor by using GCFs. Right from the jump, we don't have a GCF. Actually, maybe we do. If you can see one, I'd be glad to take it. But if not, we'll try to work with our tactics. Can anyone see a GCF? Because we always try to find that first. If not, we're going to move on to our X tactic. Okay, so no GCFs visible. Let's move on to the X tactic. Ready? Here we go. To factor a trinomial, we have to do the first times the last. Let's do that. We're going to put it in right here. So my first number is 6. My last number is 4. What's 6 times 4? Yeah, good call, Anna. 24. Boom. Multiply first times last. Check. The next steps really are the following. Take the middle number, the b value, the 14 in this case, and bring it on down. Sweet. Now, step numbers 2 and 3 say the following. Okay, take that top, 24, find the factors that equal the middle, 14. The whole point of this is to expand this 14 into 2 terms. So we can have 4 terms and then make 2 groups of 2, even groups. Because right now we only have 3 terms. 3 things don't group up evenly because it's an odd number. So can anyone think of factors of 24 that add up to 14? Factors of 24 that add up to 14. What do we got? What do we got? I'm gonna claim that it's possible. I just want to see if y'all can give it to me what it is, or what they are, I guess, because there's 2 factors. Yeah, Andrew, good job. 12 and 2. Nice, man. So here's the kicker. 2 times 12 does give you 24. Sweet. Those are factors of 24. And 2 plus 12 does give you 14. Good job, dude. Great eye. So what we now do is we fill in the sides of our x. Sweet. And the whole purpose of this is the following. Now we know we can take that middle term, 14x, and expand it. And expand it into what? The 2 numbers that Andrew just gave me. A positive 2x, because remember there's an x there, and a positive 12x. The whole point of the X tactic is to get us to this point right here, so that way we can group. Now let's group it up. Ready? Let me just copy this, right down low. Now let's group it up. 2 groups of 2 things. Number 1 term, number 2 term, number 3 term, number 4 term. And each group, each parentheses, has 2 of those in there. So we're trying to make even groups so we can factor out back to our beloved factoring form of GCFs. So real quick, we've done all of these steps already right here. We did number 1. We found the factors from step 1 that added up, and then we replaced the coefficient here. Technically, we've actually done 1 through 4 there on our steps. Now all we got to do is number 5, factor by grouping. So, anyone think they know what GCFs we could take out of my first parentheses? What can I take out of my first group here? Great call, Andrew. We could take a 2 out, but Anna, you're right on top of it. We could take a 2 and an X out. Because look at this right here. Both 6 and 2, both the 6 and the 2 can be divided by 2. We take a 2 out of there and there. And she also pointed out the fact that they both have an X in it. So we could take out the number 2 and the value X from both. And she's right on it with his answers. When you have 6x squared and you factor out, aka divide by 2x, here's what happens. 6 divided by 2 is 3. And x squared divided by x gets rid of that exponent, 3x. Nice. What happens when we take the second term? Remember, factoring is just opposite of multiplication. 2x divided by 2x, well, 2 divided by 2 is 1, x divided by x is 1, aka anything divided by itself is 1. So when you take out the term 2x from itself, well, naturally all you're going to have left is 1. Looks like, Francis, you have given me the second group. So Francis basically said the following. From this second group over here, what can we take out of both 12x and 4? He said 4. And sure enough, what happens when you divide 12x by 4? Well, the numbers can be taken down. That gives you 3 with an x left. Sweet. And what happens when you divide 4 by itself? Anything divided by itself is always 1, which Francis showed there in his answer that he typed up in the chat box as well. Hey, good job, team. Now, next thing I want to ask is, what do y'all notice about these parentheses? They're the same. That's the goal. That's always the goal. If they're not the same, you didn't do something right in these factoring problems, because at this point in math, it should all be factorable. So when they are the same, guess what we can do? Combine those numbers in front, take out the GCFs, boom, boom, and get exactly what Anna just wrote there on the board. We have our factored form. Once the parentheses are the same, you can take out the GCFs that y'all just factored and combine it with those parentheses, because effectively the logic is as follows. If you say, all right, take 15, we could factor 15 and do 5 times 3. Is that the same thing as 5 times 1 plus 5 times 2? Yeah, because really what we can do is say the following. Oh, since these 5s are the same, we can just add the 1 and the 2. It's kind of the same logic and say, oh, that's the same thing as 5 times 3 or 15. So what we're really doing is we're using the distributive property to our advantage, just in a weird backwards way, to make factoring something that's very difficult in eyesight possible. Now, if this works, they're factors, that means they should multiply to get back to the original spot. Technically speaking, if we did this correctly, we should be able to distribute and get right back to our starting trinomial, okay? So we're gonna just check that real quick. Ready? 2x times 3x, 2 times 3 is 6, x times x is x squared. 2x times 1, anything times 1 is equal to self, so 2x. This is what we did a couple weeks ago, our distribution, our FOIL, so to speak. 4 times 3 is 12, x comes along for the ride. And last but not least, 4 times 1 is 4. Now, first and foremost, take a look at this thing. Boom. That is what we were actually getting to factor. We expanded it to get there to factor by grouping. But also, even if we combine these like terms, 2x and 12x, we would get 14x. And then sure enough, did we get right back to the problem we started with? Yeah, we did. So if you do the factoring correct, you should always basically get right back to where you started. Let's get rid of all this unnecessary writing here, because our answer was the factors without them being multiplied. Here is our money answer right there. So that's where we're trying to work towards. Basically, what we were trying to work towards on Thursday, and what we're trying to get better at today, and we will continue on next Thursday, is really so to the point that if you've been an active participant in these classes, or you've watched the videos and completed the ed puzzles along with the assignments, that doing this factoring thing eventually becomes second nature. And although it's hard at first, we start to make serious progress and feel really comfortable with expanding that middle term, kind of look for my laser pointer, expanding that middle term of 14 into two terms that add up to that number, but are the factors of the outsides. Sometimes they're called the Oreo method. Outside, outside, expand it, factor by grouping, take out GCFs. All right then, on that note, that pretty much takes us to back to the textbook. All right, so here we go, page 561. Page 561, I want to find the I want to try to basically factor this equation here. So we're going to try to do numbers 9 and number 10. Can we factor those two? They're very similar equations, but they're slightly different in one way. And that one way is the sign in front of the b value. One's positive 5, one's negative 5. Okay. Let's do this. So here we go. Notice number 9, no GCF. Can't take anything out of all three terms, so we resort to factoring by grouping. So here, let's do this. Ready? Over on the right here. Let's make our little X chart. We're going to do the first number, which is 1. So for those of you who've done that Edpuzzle, that's our A value, our B value, and our C value. And I like to write it like that because it's easy as ABC. A is the first, B is the second, C is the third. So we take our first number A times our last number, which is negative 24. 1 times negative 24, our first number I meant was 1, not A, that's a variable. 1 times negative 24 is just negative 24. And now we're trying to find the factors of negative 24 that add up to what? 5. Anyone know the factors of negative 24 that add up to 5? Yes, sir, Francis. Good job. I like the 8, I like the 3. And 8, negative 8 times 3 does give us negative 24, but if we added these two, would we get positive 5? Remember, we want that 5 to be positive. So you're right, 1 has to be negative and 1 has to be positive. So I like that. Let's put the negative right there. But instead of the 8 being negative, the 3 is going to be negative. Francis and Andrew coming through. Teamwork there gets us to where we need to be. Great job. So good job, guys. So now what we've done is we have taken the ability to rewrite this red trinomial, this red equation as follows. Y equals x squared plus 5x minus 24, but now allowing us to expand that middle term. What used to be a 5 has now been expanded into 8x and negative 3x. Now let's do rapid fire. Let's not use blue. Let's do rapid fire grouping. Boom, group. 2 groups of 2. What can I take out of the first group? An x, leaving me with x plus 8. What can I take out of the second group? Anyone know what I can take out of the second group here? Remember, I want my parenthesis. I already know what my parenthesis has to be. It has to be a positive x and a positive 8. So we can use that to our advantage. Andrew's right. If we know that we want this negative 3x to become positive x, well, we got to get rid of the negative 3. And sure enough, if you take negative 24 and divide it by negative 3, do you get positive 8? No doubt. Last but not least, we combine the numbers in front, the values in front, x and minus 3, and stack them with the x plus 8. By the way, y'all, here's a shortcut. I spent so much time going over the steps of doing this. There's always a shortcut, and the shortcut is as follows. Okay, let me just cut all of this out real quick. Because if you could follow everything we just did, here's the shortcut. If you have a 1 in front, right here, boom, right there, okay? If that is a 1 in front, then you can always use your shortcut, and this is what the shortcut tells us. You take these numbers here, positive 8 and negative 3, and just drop them right after the x's. It always works every single time. which means theoretically speaking, we could do this one super quick. What am I going to fill the top with? My first number, A, 1, times my last number, my C value, which is negative 24. Signs are super important. You also keep that in mind. And we're trying to find the factors that add up to the middle, negative 5. So what are the factors of negative 24 that add up to negative 5? Francis gave us this one already. The factors of negative 24 that add up to negative 5 are negative 8 and 3. Because negative 8 times 3 does give us negative 24. Check. And negative 8 plus 3 does give us the bottom value, negative 5. Check. And let me ask you a question, y'all. Is my, get this tail off. I'm just trying to mess with that. It didn't work. Is my leading coefficient, my number in front, my A value 1? It is. So that's really good news because now all I got to do is drop my numbers in x minus 8. And is that 3 positive or negative? It's positive, so I'll use a plus to make sure I know it's positive. Boom, there's the factors. The shortcut works 100% of the time if your number in front is a 1. So really, if your number in front is a 1, it's the best case scenario. You just find the factors that of this number that add up to that number, and you throw them after the variable. Okay. Sweet. Okay. Number 11, page 562. Number 11, number 13. What I think I'm going to do here, y'all, is I'm actually going to break you out, okay? I'm going to break you out into separate rooms for like 5 minutes, and I'm going to have you try to work together to do numbers 11 and 13, okay? And then I'm going to come in and check and give you some help. So I'm going to break you out into groups right now, into groups of 4, and yeah, here we go. I'll see you in a few minutes. I'll be coming around. Try numbers on page 562. Numbers 11 and 13. Again, one more time. Page 562, numbers 11 and 13. I'll be jumping around from room to room to help. Let's go. Join those rooms. Join those rooms. AJ and Emily, make sure you join them. Hey, y'all. Francis, looks like you're in here by yourself. I thought I had a few other people in here.
Yeah, no one here.
Huh.
I already finished the first one anyways.
Let me see. Let me see if I can help fix that out for you. Nope, nope. Looks like we must have lost our other person in here then.
I think Anna was here before, and then left.
Yeah, I think she might have left on accident. Do you know how to do numbers 11 or 13?
I already finished the first one.
What'd you get?
Huh?
What'd you get?
The first one I got, let's see, I have,
Hey, AJ.
oh, hey. I got, x plus x, which is technically just x squared,
Uh-huh.
times, what did I say? Well, x plus 4, times x plus 4.
Super close. Remember, you're trying to find
it's 1 plus 4, sorry.
You're trying to find the factors of 4 that add up to 4, right? So what are the factors of 4 that add up to 4 for number 11?
4 and 1. No, dang it. Why did I mess that up?
There you go. You got it.
Sorry.
All right, I'm going to go check out another room, okay? So, AJ, we're doing page 562, number 11 right now. You and Francis are working on that problem. I'll be right back, though, guys. We're going to end this breakout room in just a second. I'm going to check on the other ones. I'll be back. Hey, Ashley. Hey, Juliet. Any success on this one? Number 11 or 13?
I'm stuck on number 11 trying to figure out a GCF for 4.
Gotcha. Okay, so we know that we're trying to find the factors of 4 that add up to 4, right?
Yeah.
Yeah, so what are those factors, do you think?
I was thinking like a negative number probably because 1 times 4 works, but 1 plus 4 equals 5.
True. So are there any other factors of 4, though? You're right, negatives could be thrown in the mix, but
Oh, 2.
there we go. And does 2 plus 2 equal that middle term?
Yeah.
There we go. So yeah, so we're gonna be able to expand that to x squared plus 2x plus 2x plus 4. But also if you know the shortcut, you know that both the numbers are 2. So really your factored form could be x plus 2 times x plus 2.
Okay.
I'll bring it back. When we bring it back, I'll show it visually too as well. Okay, so 2 and 2, try working from the groups there.
Okay, thank you.
We're about a couple minutes and then we'll go back to the main group. I'm just gonna join the other group real quick. Hello, everybody. Are we having any progress on numbers 11 or 13?
Hey, Mr. B.
Hey, Andrew, your mic's working now. Right on.
Yes.
Any progress? Any luck on numbers 11 and 13 on page 562?
Not really. I'm stuck. I can't figure it out.
Fair enough. In about a minute, we're gonna come back as a whole group. But does Ella, Ava, Yup, Sarah, do y'all know? Any luck on those?
No.
No. Okay, fine. That's totally cool. I'm gonna close all rooms. We're gonna come back. Here we go. Thank you, Ella. Totally was on mute. Sorry about that, y'all. So my bad about being on mute there, but hopefully what you can see on the screen here as we finish up for our lesson today is I took the first number, 1, my last number, 4, got the product of 4, and now we're trying to find the factors of this red 4 that add up to our middle 4, green there, and the factors there are 2 and 2. So now what we can do is expand our x squared plus 4x plus 4 into x squared plus 2x plus 2x plus 4. Make some groups, group number 1, group number 2, and then take out the GCF from each individual group. And in this case, our GCF from our first group is, hey, they both have an x, so let's take an x out, leaving me with just x plus 2. What could I take out of both terms over here, 2x and 4, keeping in mind that we want our parenthesis, what's left over on the inside, the same as x plus 2. What would I have to take out there, y'all? 2, good call, Andrew. And then we can combine the GCFs, which I have written in red, x and a positive 2, with the parentheses, which are written in blue, so I'll keep it in blue as x plus 2. Boom, we now know the factored form of that equation. So this is actually where we're going to leave off for today. On Thursday, we're going to continue working through this to continue mastering our knowledge of factoring. And then eventually, I know it seems like it's been a long time coming, we'll actually learn why in the world we're doing this, connecting it with that vocab word that we call a root to allow us to solve for these equations by using algebraic properties. So on that note, I do appreciate how hard y'all worked today and all of your time in being here. So if you have any questions, feel free to stick around. If not, have a great rest of your day. Keep working hard, and I look forward to seeing y'all on Thursday, okay? Again, thank you all so much for being here.
Have a good day.
Thanks, Francis. You too.